Okay, today we're going to talk about arithmetic. We're going to learn arithmetic, but we're going to learn the arithmetic of vectors, and it's different than the arithmetic for scalars. Let's review. What is a scalar? A scalar is something as a measurement that has magnitude only. No spatial direction. An example of that is time. Like we have 20 minutes left in class. You would say, well, we have 20 minutes to the north in class. You would never say that. It doesn't make sense to give it a spatial direction. But if I was to ask, what is the location of, or what, how do I go from my desk here to the door of the room to get out in 20 minutes? Well, I'd say, you got to walk about 12 meters in that direction, over there. Okay. So, in other words, to give a position or a displacement or something, you need to have both. For a vector, you need magnitude. Wait, is it magnitude? I am a terrible speller. I'm really bad. So if I spell something wrong, please let me know. Magnitude and direction. Now, we've been doing one-dimensional kinematics so far, where whether it's what direction it's in, we've denoted with a positive or a negative, right? It's in the positive x direction or the negative x direction. But now we're gonna do that with 2 dimensions here in just a minute. Okay, and now let's talk about scalar arithmetic. If I have 3 apples plus 4 apples, how many apples do I have? 7. Somebody said 10. So you should transfer right now. All right. 3 apples, 4 apples. Now, and notice that they have to be apples and apples. You can't add apples and oranges. You can't say, well, you can say, how many pieces of fruit do I have? That would make, I guess it depends on how you define it. But this, it has to be the same thing. Now, this is a scalar, and you learned what this plus sign means. This plus sign is an operator. The plus sign tells you what to do with the other numbers. And what it's telling you to do is say, well, 1, 2, 3, 1, 2, 3, 4, and then you count them. 1, 2, 3, 4, 5, 6, 7. 7 apples. Okay? Now, you memorize math facts so you don't have to draw silly little dots and do this. But in reality, this is what you're doing when you are doing scalar arithmetic. That's one way of defining what a scalar addition is. But what if I told you that 3 plus 4 does equal 7, but I can give you an example where 3 plus 4 equals -1. And I can give you an example where 3 plus 4 equals +1. I can give you where 3 plus 4 equals 5. What? So you're going to go home and say, well, what'd you learn in physics today? And you can say, well, I learned that math is completely screwed up. Okay? This, you can tell, this is Common Core math. Oh. Now, here's what this is. We're going to define something to be a vector. And I'm going to say vector A. I'm going to call them, we're just going to deal with displacement vectors for now, because those are easy to work with. So let's say vector A is this. So it's 1, 2, 3 meters long. And you can see that vector A here is represented by an arrow because an arrow has length or magnitude and it has a direction, in this case to the right. Now when does Now by the way, vectors, two vectors, when are two vectors equal to each other? Well, if I pick this vector up and just put it somewhere else, same length, I'm trying to draw it the same length, and same direction. These two vectors, they might look like they're different, but they're not different. We define a vector as having a magnitude and a direction. If two vectors have the same magnitude and the same direction, they are equal to each other. So if this is vector A and this is same magnitude, this is also vector A. Okay, you can just pick them up and set them down. As long as they're in the same direction, same magnitude, they're equal. Make sense? So they don't have to be at the same place to be equal. Now let's say this is vector B. And vector B is 1, 2, 3, 4 meters long. It's a displacement vector. Now what do you notice about vector A and vector B? They are in the same direction. Now what if I added these two displacements together? What if I walk 3 meters, let's say, to the west? I walk 3 meters to the west, and then I walk 4 meters to the west. How many meters did I walk? I went 7 meters to the west, correct? Right? Okay, so let's do that. Let's go A plus B. Vector A plus vector B. And I'm going to say vector A. I'm just going to pick it up. And then I'm going to pick up vector B. And I'm just going to lay it down like this. And so this is now 1, 2, 3, 4, 5, 6, 7. I went a total distance of 7 meters to the right. Does that make sense? Okay. And so look what I did, though. I took vector A, and then I'm going to call this the tail, the back end here of the vector, where the vector starts. That's the tail. And then we call this an arrowhead. We call this the head of the arrow. And so what you want to do when you add two vectors together is you hook them up, head to tail. You put the head of the second one on the, you put the tail of the second one on the head of the first one. Zoom in so you can read it better. Okay, does that make sense? So here's vector A, and then here's vector B. Now the answer, we usually call, when I add two vectors together, I usually call that vector R. And why? What does R stand for? R stands for resultant vector. It's the result of adding those two vectors together. Now, what if vector A, we'll keep it the same, but what if I made vector B look like this? It's the same magnitude, but let's say we change the direction around. What am I going to get how do I add vector A plus B? I want to put A, but then I hook them up head to tail. So the tail of A goes at the head of, the tail of B hooks up onto the head of A, and it just goes back. So there's B. So what did I do? Oh, I went this, what's R? R is in that direction. R is now equal to -1. See here, when A and B were in the same direction, they just added together like scalars add. Two vectors are in the same direction, you just add them like scalars. But here, if one is in the opposite direction, you go A plus B, you get, in this case, -1, right? Now I'm going to skip, if I go 3 plus 4, but I make A negative and B positive, you'll get +1. But let me do this, 3 plus 4 equals 5. How do I get that? I'll do it down here. Let's say that A looks like this. 3 units of length to the right is vector A. But let's say B looks like this. 4 units, but straight up. Now what's my answer? What is of A plus B? We'll hook them up head to tail. Hook them up head to tail. That is the algorithm. That is what the plus sign means now. If you have a plus sign between two vectors, it's telling you to hook them up head to tail and see what you get. Now in this case, A, plus B, pick it up, put it down there. So here's A equals 3 meters, and B equals 4 meters, but now they're at a 90-degree angle, right? So what's this going to be? 3, 4, well, it's a 3, 4, 5 triangle. I mean, you can do Pythagorean theorem if you want. This is 5. And this is how you get 3 plus 4 equals 5, but only if you're adding vectors, and only if 3 and the first vector and the second vector, let's make this vector A, and this vector B. If you go A plus B, if you change the direction of B, you get these different answers. Okay? And it doesn't matter what order you add them. A plus B equals B plus A. If I wrote B first, let's write down B. Here's B. And then I add A to it. Look, I get the same result. So A plus B equals B plus A. It doesn't matter what order. So this is the commutative property of vector addition. And if I have more than one vector, or more than 2 vectors, I can just add them together like this. I can say, okay, here's vector A plus vector B plus vector C plus vector D plus vector E, and then you add them all up, hook them all up, head to tail. There's a whole bunch of them. You just hook them all up head to tail. And then you say, okay, where did I end up? I ended up right here. Where did I start? I started right here. So it's from where you start to where you end up. That's your resultant. Oh, I'm sorry. A plus B plus C plus D plus E. Okay, well, that equals that. And I'll leave it to you. If you draw some vectors, add them together, get a result. Now, add them in a different order. But if you're really careful, the resultant vector will be the same length, and it will be in the same direction. Okay. Now, let's talk about vector subtraction. This is how you add vectors. How do I subtract vectors? Oops. Hey, if I'm off screen when I'm writing, just say off screen real quick. Okay, so subtract vectors. So what if I want to go A minus B? Well, now this we have an operational definition for subtraction that we use for scalars, but we're now using vectors, so it's a different operation. We're using the same symbol, but we're going to do something different. Now what we're going to do, by definition, this is going to be, pay attention, A plus negative B. Well, what is negative B? What is negative B compared to positive B? It has the same magnitude, but opposite in direction. So if we let this be B, okay, 1, 2, 3, 4. If this is B, then this, we just take it and flip it around. It's still, 1, 2, 3, 4 units long, but this is negative b. Okay. So, if this was b. Now, I'm changing the direction of b, for all my different examples, which is kind of irritating. But let's do a minus b, but it looks like this. Let's say a is 1, 2, 3 units long, and b looks like this. 1, 2, 3, 4 units up. This is a, and this is b. And I want to go, what is a minus b? So you take a, you lay it down, just start with a again. Now b is here, but what is negative b? Negative b would look like that. So we want to add negative b. And so our answers, if this is a plus negative b, and there's my resultant vector. Okay, I got 2 little things to do, and I got 4 minutes left. I'm going to use them. You'll get out of here on time, no worries. Let's talk about vector multiplication. If we take a scalar times a vector, let's say I've got 3a, 3 times vector a. Well, what does this mean? Well, the 3 is a scalar. Let's say that a is the same vector we've been using. Well, what is this equal to? Well, vector a plus vector a plus vector a. You're just adding a to itself 3 times. Or, if it was 3.1 times a, you would go 3 and then 1/10 of another a. And you're just going to add them. Oh, okay, if a, if this is my a vector again, I'm just going to go a plus a plus a. 1, 2, 3, 4, 5, 6, 7, 8, 9. So when I multiply the vector by a scalar, like this, all I'm doing is changing the length of the vector. I'm multiplying the magnitude of the vector by this, so it becomes a long, here's my answer, right? 9. But I'm not changing the direction. Okay? Now, what do you need to do? Well, some of the homework asks you to make a scale drawing and add vectors and figure out what the answer is. Now, later on, we're going to add vectors mathematically. We're going to use trigonometry, we're going to x and y components, and add the x components and the y components, and then go through this, stuff. But for this, you won't need to do that for this assignment. What you're going to need, though, is a ruler and a protractor. And then what it says is, add this vector plus this vector. You'll need to create a scale, and I don't have time to do an example problem for you, but you'll do a scale, maybe let 1 centimeter equal 3 meters or 3 kilometers or whatever makes sense for your paper. Draw an XY axis, use a protractor, measure the angles, measure the distances, use your scale to figure out what the magnitude of your answer is, use the protractor to figure out what the angle is compared to the x-axis, and just figure it out. It's not killer hard. But you have to be meticulous. You have to make a nice drawing in your notebook for these. Sometimes they'll just want you to draw a little hand sketch. If it says just to draw a sketch, then what I did here is good enough. But if they want, as exact as you can get drawing pictures, then you got to use these guys. Any questions? Okay, have fun adding vectors over the weekend. Bye. That is all.